Hi everyone, it's Mrs. Marcellus, and I'd like to introduce you to my good friend Froganachi. He's going to be with us for our unit on integers. Today we're going to learn about integers and graphing. The learning objective is, students will write integers for given situations and explain the meaning of zero by analyzing the situation. Students will also represent integers by graphing them on a number line. You might be wondering, just what is an integer? An integer is any number from the set -3, -2, -1, 0, 1, 2, 3, and so on. As you can see, these are all whole units. Decimals and fractions are not integers. Positive integers are integers greater than 0, and negative integers are integers less than 0. So if we take a look at our number line, we can see that 0 is neither positive or negative. It's neutral. It doesn't have a sign that goes with it. The negative integers go to the left. The further left you go, the less the value becomes. Positive integers go to the right. The further right you go, the greater the value becomes. Let's take a look at writing some integers. Integers can be used to represent many real-life situations. The first thing we're going to do is analyze a situation and write an integer for it. We also will explain the meaning of 0 relative to the situation. For example, suppose we have a loss of 15 yards in football. To determine whether this will be a positive or negative integer, we look for key words. The situation says a loss of 15 yards. This would be a negative integer. We would represent a loss of 15 yards with the integer -15. Then we'll explain the meaning of 0 relative to the situation. When we're explaining the meaning of 0, it doesn't mean the actual value of 0. It means 0 in the situation we are currently talking about. This would mean there is a play that resulted in 0 yards. Therefore, the meaning of 0 would be that no yards were lost or gained. Let's say we have a bank deposit of $25. When you deposit money in the bank, you are adding to your bank balance and your bank balance increases. When you withdraw money from the bank, you are subtracting money from your bank balance and your bank balance decreases. Since we are depositing or adding money to our bank balance, this would be represented with a positive integer. You can write either positive 25 with a plus sign in front of it, or you can write just 25. It is assumed that all numbers are positive unless they have a negative sign in front of them to tell us otherwise. The meaning of 0 in this case would be no money was deposited or withdrawn. Let's write an integer and explain the meaning of 0 for 8 inches less than the average snowfall total. Since this is less than the average snowfall total, we would be on the negative side. We will represent this with the integer -8. The meaning of 0 in this situation is the average snowfall total. That is the benchmark against which we compare. Are we below average, above average, or at average? Let's write an integer and explain the meaning of 0 for an increase of 20 degrees. The word increase indicates a positive integer, so we would write plus 20 or simply 20. The meaning of 0 in this case is the temperature does not increase or decrease. It simply remains the same. We can also graph integers on a number line. Let's say we want to graph -3 on the number line. If you are given a number line with numbers on it, you would simply place a dot where the -3 is. However, sometimes you're given number lines without numbers on them, so the first thing you'll need to do is label them. It really doesn't matter where you start and end as long as -3 is included somewhere on your number line. For example, I might number this number line with -5 and so on. Then I will place a dot at -3. This is how we graph an integer on a number line. Sometimes you'll be given a set of integers to graph. In this case, you have to look at the set of integers and find the smallest and the biggest integer and make sure that you can fit that range on your graph. It looks to me like if I start with -4, I will be able to fit everything on the number line. Now that I have my number line numbered, I will go ahead and graph the three integers. I will place a dot at 1, at 0, and at -4. Number lines can also be vertical. Let's graph 8, -2, 1, and -4 on the number line given. My largest value is 8 and my smallest value is -4. So it's not going to fit on the number line if we go by ones. We'll have to think of another way to number our number line. We could go by 2s, by 3s, by 4s, whatever will work with the numbers. I'm going to try going by 2s and label my number line. The higher you go on a vertical number line, the greater the value. The lower you go on a vertical number line, the lower the value. So I'm going to start with 8 and go ahead and label my number line. It doesn't really matter whether you put the numbers on the left or the right of the number line. Now that I have my number line numbered, I can go ahead and graph the integers in the set. First I will put a dot at 8, and then at -2, at 1, and you can see that we don't have a hash mark for 1, so we have to go halfway between 0 and 2, and finally -4. We have now successfully graphed this set of numbers on our vertical number line. Sample data shows the number of tadpoles at a local pond has been below average for 4 years. Graph the amounts below average on the number line. The first thing we need to do is look at our data. We can see that these are all negative numbers and that the counts have been quite low compared to average. It looks like if we go by ones, this set of data will fit on the number line. So we'll need to label our number line before we can graph the data. Now that we have our number line numbered, we can go ahead and graph the integers. We'll go to -25 and draw a dot. Then we'll draw a dot at -27, -30, and -31. And now we have successfully graphed the tadpole count data on the number line. Well, Froganachi, I'm sorry to see that tadpole count data. That means less frogs for the future, doesn't it? So far we've learned what an integer is and how to graph it on a number line. We'll continue with absolute value in our next lesson. Bye for now, math students.